Okay. Today we're going to talk about properties of parallelograms, rectangles, and rhombuses, squares. Notice that today it doesn't say we're starting out with a quadrilateral. It says, if I start out with a what? So they're telling me that RH is parallel to MO. They're telling me that RM is parallel to HO. That part is given to me. And they're saying if that is given to me, and I know an additional piece of information, if I know that RO is perpendicular to HM, that this shape will in fact be a rhombus. It doesn't work to just have them perpendicular. You had to know that it's what first? A parallelogram. Because there are other objects that have perpendicular diagonals, such as a kite. The diagonals of a kite are going to be perpendicular, but certainly it's not a rhombus. So we've got to start out with it being a parallelogram. Finding that the diagonals are perpendicular will force it to be a rhombus. And in each one of these three that we're going to talk about today, it starts out with a what? So I automatically know that it's a parallelogram to start with. And then it's kind of using that property that we learned about the rhombus backwards, or the property that we learned about a rectangle backwards. We knew if it was a rectangle that diagonals would be equal, but if it is a parallelogram and diagonals are equal, then I know it's a rectangle. If I know it's a parallelogram and opposite angles are bisected, then I know for sure that this is a rhombus. If I know that these are equal to each other, I know that this is a rhombus. In fact, if these two are equal to each other, and this was a parallelogram, these will in fact also be the same. So if I told you one of these was 40 degrees, all of these would be what? 40 degrees. If I start out with a parallelogram and I find out that in my parallelogram that the diagonal RO is the same as the diagonal MH, then I know that this parallelogram is forced into being a rectangle. And if it's forced into being a rectangle, all of these angles will be 90 degrees. Everybody good? Questions? Okay. Here it's asking me, can I conclude that the parallelogram, so they're saying in each one of these start out as being a what? Parallelogram. Is there enough information to conclude that the parallelogram is either a rhombus, a rectangle, or a square? Is there enough information in example 1? What is it? It is a rhombus. And it's a rhombus because it bisects opposite angles. Specifically, the diagonals bisect opposite angles. Example 2. They told me it was a parallelogram. Is there enough information to say whether it's a rhombus, a rectangle, or a square? What is it? It's a rhombus. And how do I know for sure it's a rhombus? The diagonals are perpendicular. Example 3, they said that this was a parallelogram. Be careful before you answer this one. Is there enough information to state that this one's a rhombus, a rectangle, or a square? What does it take to make this a rectangle? Okay, and I don't know that. Okay, does it show that the diagonals are congruent? It shows that it bisects, but does it show that this diagonal is the same as this diagonal?
No, absolutely not.
So, I heard how.
Yeah.
Okay. Because these two are the same, let's say that this was 5 and this was what? 5. Did it tell me the relationship between here and here? All I know that is these two are what? The same. This one could be 7 and this could be what? 7. Do you see it? They do not say that all 4 of these pieces are congruent. If I wanted that to be a rectangle, instead of being marked like it is, now would it be a rectangle? Yes, because I know that the diagonals are congruent to each other. But they didn't mark it that way, so there wasn't enough information. I do know that it's a parallelogram, but that is all I would know. Example 4. Again, they told me that this was a parallelogram to start with. Is there enough information to state whether it's a rectangle, a rhombus, or a square? AD and CB are the same length.
So that means it's a rectangle.
It's a rectangle. Why?
Because the diagonals are the same.
Diagonals are congruent.
Smart.
Everybody good? Okay. In example 5 and example 6, notice they're talking about a special parallelogram. So in order to do example 5, you had to know that this is a rhombus to start with, or you can't do it. If, in fact, this is a rhombus, what would I know about the two angles where they've given me information? They're equal to each other. And if two things are equal to each other, we simply set them equal to each other. And we solve for that variable. Yes, 6x minus 9 and 2x plus 39. And I'm going to subtract 2x from both sides, leaving me 4x minus 9 is equal to 39. If I add 9 to both sides, 4x is equal to 48. So when I divide by 4, x is going to be 12. So each one of these variables is 12. I could find the angle measurement by plugging it back in. Be careful before you go to do example 6. If this is a rhombus, what do I know about the diagonals? They are perpendicular. I do know that they bisect opposite angles, but I don't know the relationship between this angle and the one that they've given me. I just know that it cut those into 2 equal parts. But I do know the relationship in a triangle. How many degrees are in a triangle? 180. How many have I used up because this is a right triangle? So what can you tell me about the remaining 2? They've got to add up to equal 90 degrees. 8x plus 7 plus the 3x plus 6 has to be equal to 90 degrees. Or you could have added these two and the 90 and set it equal to 180. Combining like terms, 8x and 3x is 11x. 6 and 7 is 13. If I subtract 13 from both sides, 11x is equal to 77, which means x is going to be 7. Questions on example 5 or 6? In examples, yep, question?
Okay, so on example 6, I can I just add all three of the numbers, like the first equation, second equation, and 90?
Right, you could have done this. 3x plus 6 plus 8x plus 7 plus 90 equals what? 180. You certainly could have done that. In example 7, they told me that this was a rectangle. If it's a rectangle, I know that this is 90 degrees. What do I know about the diagonals? They're all equal and they bisect each other, so each one of these 4 pieces are the same. What type of triangle have I highlighted? So what can you tell me about this angle that we've marked and this angle that we've marked? They're equal. And if 2 things are equal, what are we going to do with them? Set them equal. 4x minus 12 equals 3x plus 4. Subtracting 3x. X minus 12 is equal to 4. Adding 12, x is equal to 16. Everybody okay with example 7? In example 8, this is a rectangle. So what do I know about all of the angles? They're all 90 degrees. What am I going to do with these 2 angles then that are here? I'm going to add them together and set them equal to 90 degrees, because the 2 of them have to add up to 90. So 3x and 5x is 8x, plus 2 equals 90. Subtracting 2, question? Why aren't they going to equal each other? Okay. If this was a square, they would equal each other. If it was a rhombus, they would equal each other. Because it's a rectangle, the only thing that I know is that all 4 of the angles are 90 degrees. And I know that all of the diagonals were congruent, so each of the pieces were the same. So although I know that this angle is the same as this angle, I don't know its relationship to this angle. I do know that these 2 are the same because it's an isosceles triangle. In fact, they would be the same as these 2. Likewise, these 2 would be the same as these 2. But I do not know that these 2 are equal to each other. If they were equal to each other, they would be 45 degrees. And the only time that would happen is if this rectangle became a square. So if I subtract 2, I now have 8x equals 88. So when I divide by 8, x is 11. Everybody good?
Yes.
So, no, that is it today. Your assignment is 6.5 Form G. It is 1 through 10 and 13 through 19.